Okay, we'll come to desk. Your desk is a mess.
Mm-hmm. Two clears the classes there? No. Oh, they are. On the floor. Hi, Chase.
How you doing?
I'm doing fine. I wrote that message on the chat line before I realized, hey, if you're not in here, you can't determine that. So never mind. How you doing?
Pretty good.
Okay, there are three things I need to talk about today. Make sure you remind me. One of them is something called the sum of the coefficients. The other one is the molar volume. And there's a third thing.
Is this new material or is this?
It is new material.
Oh.
It's not going to be that, it's not that difficult. I swear to God. I swear to God, it is not that difficult. Okay.
Professor.
Yes, sir.
Could you go over chemical reactions?
You mean the thing I took 3 lectures doing?
Yeah, I'm still, it's one of those things, it's like, I understand it. I was up till like 2 a.m. last night just trying to get it down, but I can't,
I remember the third thing. Sorry, I just remembered this third thing.
It's one of those things, it's like, I understand it,
okay,
but I don't understand it.
Okay. Okay. Let's get into the bottom here. Okay. I'm not, I haven't shared screen yet. Victoria, you in here?
Hi, Professor.
Hi. How's it going?
It's going. I did the practice test.
Uh-huh.
And I feel slightly more confident than I did earlier. But I think one of the questions I had was, because we haven't gotten over it yet, but the like when you're taking kilograms and making them into molecules.
Whoa, 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 whoa. We did do that.
Okay.
Okay, let me get Chase's question first. Ormethea, how are you doing?
I'm good.
Okay. Chase, I'm going to go through a review with this. Okay? All right. First thing you got to recognize. Are you seeing the screen?
Yes.
All right. First of all, you got to recognize ionic plus ionic. Double replacement. Okay?
Okay.
Metal plus an ionic. Single replacement. Halogen plus an ionic. Also single replacement. Halogen. Let's see. Acid plus a base, acid base. Hydrocarbon. Plus oxygen. Combustion. And bigger thing. To smaller thing. Decomposition. Smaller thing to bigger thing. Synthesis. Okay? Does that make sense to you, Chase?
Yeah.
Those are all the recognitions. Now, based upon your recognition, you have to figure out what the products are. Double replacement. You switch cation and anion.
Hold on, just 1 second. My mom's calling me.
Okay. Victoria, you're up.
Okay, so it's the last question on the practice exam. I was off by like 0.200, and I am confused of how to get there.
Okay, what is the question?
It's 3.852 kilograms of barium chloride, and chlorine has a 2 subscript.
Let's give me the numbers again. It didn't.
Oh, 3.852 kilograms of barium chloride into molecules of barium chloride.
Okay. First thing you got to do, you can't do anything in kilograms. Can't do anything in kilograms. Got to change that to grams.
Right.
Because grams are what atomic and molecular weights are made out of.
Mm-hmm.
Okay. So the first thing you got to do, 3.852 kilograms.
Do you times that by 1,000? Okay.
Absolutely. Remember, you're going up the stair ladder. If you're going up the stair ladder, I'm sorry, you're going down the stair ladder. If you're going down the stair ladder, you multiply 10 by 10 each time.
Okay.
So this makes 3.852 grams.
Okay. So
now,
then I took that. I took the molecular weight of barium and chlorine,
which is 71 plus 133.
Oh gosh.
137.
Yeah, 137.327. Plus chlorine times 2, which I got 70.906.
Okay, I'll buy that. So you got 208.2237.
I got two. Well, hold on. I got 208.237.
That's what I said. 200.
Oh, sorry. Oh, sorry. 0.233 somehow. But
okay. Now, is there a relationship between number of molecules and atomic or molecular weight?
It's Avogadro's number, right?
So you get 3.852 grams, 3,000.
Yeah.
And you want?
I put the molecular weight over Avogadro's number.
No. Can't
I
do
flip
it that
it?
way. Yeah, because Avogadro's number is the number of molecules.
I thought you had it. Oh, okay. Never mind. I see what I did wrong.
Molecules divided by 208.237 grams.
Okay.
Okay,
I just
that's how you set that up, Victoria.
Okay, I just flipped them on accident.
Okay.
Okay. I think that's it.
Okay.
So I was doing, until I have another.
There are other people in here, Victoria. Let me get a chance to
Okay.
somebody that wants to ask a question.
Sure.
First person that speaks. First person that speaks. Okay, in that case, I'm going back to Chase. Chase, you there?
Yeah.
Okay, first problem. First thing you're doing with reactions, you have to recognize them. If you have an ionic compound plus an ionic, reacting them together, that's a double replacement. You have to switch the cation and the anion. In other words, the first cation and the second anion are now together. The cation in the second compound gets put with the anion of the first. That makes sense, Chase?
Yeah.
Okay, if I have a metal plus an ionic, that is a single replacement. The metal becomes the ion, and the ion becomes metal. All right? That is something like aluminum plus copper sulfate. Aluminum's a metal. Copper is an ion. Aluminum is more active than the copper, so it replaces the copper. And I now have aluminum sulfate plus copper metal.
Okay.
All right. Single replacement. Halogen plus an ionic. A halogen is something that's in the last column. They have to be diatomic. So you would have the halogen plus the ionic compound. In this case, halogens are more likely going to be, halogens will be anions. So the halogen will replace the anion of the ionic compound. So if I have something like chlorine plus sodium bromide, the chlorine will replace the bromide, and I will now have sodium chloride. The bromine, which was an ion, becomes the neutral Br2. Okay, Chase?
Okay.
If I have an acid and a base, you recognize that one compound begins with H, the other one ends in OH. That's an acid base. My two compounds are H2O and a salt. Basically, you take the H from the acid, hook it up with the OH from the base, you make water. There are going to be two ions that are left. Those two ions make the salt. You still with me, Chase?
Yep.
Okay. If I have a hydrocarbon plus oxygen, a hydrocarbon is a compound of hydrogen and carbon. If I have that plus oxygen as reactants, I have a combustion reaction, and my products are CO2 and water. We good there, Chase?
Mm-hmm.
Okay, if I'm going from a bigger thing to a smaller thing, if I'm going from a bigger molecule to smaller molecules, something like H2O2 going to H2 plus O2. You know, H2O2 is a big molecule. H2 small, O2 small. Bigger thing to smaller things, decomposition. If I'm going from smaller things to a bigger thing, I have Mg plus O2. This reacts to make MgO. Smaller things reacting to make a bigger thing. That is a synthesis. That in a nutshell, Chase, is our reactions, okay?
Okay.
That is 3 lectures concentrated down into 5 minutes. Okay?
Okay.
Victoria, your other question.
Yeah, I was doing the survival guide problem. I don't know if you have it with you.
Somewhere. Okay, which module?
It's module 6 on page 17.
I'm here.
Okay, so it's number 13. Since there are 2 bariums, I guess you just count each barium on that side in order to get 2 when you're balancing them.
No reaction.
Okay.
That's what I would say, no reaction.
Okay, but for balancing purposes, like if you had to...
You can't balance it. It's no reaction. If you have no reaction, Victoria, it's not balanced. What did they give you as an answer?
Hold on.
Oh, crap. Bullshit. Don't worry about it.
Okay. Because I'm looking at them like, I balanced it correctly, but I don't understand.
No.
Okay.
God. I should slap him for this.
Do it.
Basically, barium HSO4. The HSO4 is a weak acid. It will react with the OH from the other compound as an acid-base reaction. So that's why you're getting water and barium sulfate being left over.
Okay.
Does that make sense to you, Victoria?
Yeah, it made sense. It's just, I mean, I had to look at the answer to understand it, but I was like, what do you do with the barium? Do you just split it both ways, or like, do you just make it as a 2 when you're balancing it? That's what I was getting confused with.
What happens is the H from the anion, HSO4, that reacts with the OH from the barium to make water.
Okay.
So all the H's and OH's are out of there, but you have the barium swimming around in solution yet. So you have a barium from the OH that's swimming around in solution, and you have another barium from the HSO4. Okay? Those 2 bariums then latch on to SO4 and precipitate out as solids.
Oh, and then they balance each other out technically, right? Okay.
That's basically what happens.
Now, that's not going to be on the exam, is it?
No,
okay.
no.
Okay, cool.
God, no. That, honestly, I'm sorry. I looked at it first, and that's what I kind of thought was going to happen. But I thought, no, he's not going to do that to them. He's going to just say no reaction. Sorry.
No, it's okay. He like made us, there's like 5 pages worth of just balancing crap. That's all I did. I feel confident, but I was just
good for you. I know it's a pain.
It was like that lab with 127 questions. I was going cross-eyed there.
And it's not just that it's 127 questions. He's got up to O chances in some of them, up to S chances in some, and you got to wade through all that crap.
Yeah.
I just did that. I just took the, you're going to have something similar to that in the lab tonight. He's giving you all kinds of choices like that. It's ridiculous. 4 choices. There are 4 choices for all the answers in the test.
Okay, that makes me feel a little bit better.
Guys, anybody else have any questions you want to pop up? Hunter?
I was saying, thank God, because there's like 12 answers for one question.
You did great. What are you talking about?
I know, but you got to look through every single one.
Your improvement from your first attempt to your second was amazing. Hey, guys, everybody give Hunter a clap of hand. He did it twice. He did that.
Oh, no, he took it twice?
Right, Hunter?
Yeah.
Bro, you
Well, here's the truth. The first one, I literally did at like 1 in the morning. I started it thinking, oh, I got this. And then I was up until like 4. I was up until 4. Halfway through, I was like,
bullshit.
I think I was just clicking buttons. And I was like, oh man.
I told you, Gus, when I took it, I got a 90%, and that's because after question 70, I didn't care.
Yeah, that's how it got to me. And then like the playlist that I was listening to, there was like Eminem on it, and I hadn't heard that since I was like 12, and it was like, I don't know, it was like distracting.
So I'm sorry, Hunter, did you use a lot of M choices?
Yeah.
He thought he was Slim Shady.
How are we doing, ladies and gentlemen? We doing okay?
Doing all right.
Okay. Breakdown. I don't want to go into this yet because I still have people showing up. Everybody is aware that the test is on Thursday, correct?
Yes.
The test is on Thursday. What
Yep.
happened was I didn't change the testing date from HCC to there. HCC's doing this test. They're a couple of days behind you. So they're doing it next Thursday. So that's why the 10th was there. And that is why it showed up on the calendar and it showed up on that first course content as being on the 10th. So make it absolutely clear. The test is on Thursday. It goes from 8 o'clock to 7. You have until 7 to complete it. So if you want the full, I believe I gave you 2 hours for it. If you want the full 2 hours, you are going to need to begin it by 5 o'clock. Do I have that understanding?
Sure.
Yes.
Yes.
Okay. I'll get it from Christina in a second. Anybody else have any questions?
Can I go home, sir?
You can go home. Terry, you can go home. I'm not really taking roll tonight.
All right.
Except
all right.
just-
y'all have a good
except just-
spring break.
Just out of curiosity, there's one person I'm going to take roll just simply because he hasn't shown up for about a month and he has the audacity to ask me when the test is.
Wait, who's that?
I'm not saying. But on the other hand,
Terry?
he
did
brought it
hear,
to my
hold on.
attention. It was due that the date was wrong, so I should be happy. Okay, we're at 5:30. We're at 5:30, ladies and gentlemen. If you were under the mistaken impression that the test was not until the 10th, let me advise you, the test is on Thursday, March 4th. Test is Thursday, March 4th. 33 questions. 33 questions. Now, it's not as bad as it seems because the first 18 are nomenclature. You're going to see the formula. You're going to have to give me the name. I'm going to give you the name. You're going to have to give me the formula. Those aren't bad, guys.
Did you make it multiple choice?
Multiple choice.
Oh, you're the best.
Questions 19 through 27 all deal with chem reactions. Question 33 also has to deal with chem reactions. 28 through 32 has to deal with the mole and molecular weight. So, ladies and gentlemen, you are going to have to realize that the questions 28 through 32 are going to take most of your time. Don't sit and fiddle with the naming.
Okay, so hold on. Could you just, so it's nomenclature for the first part, and then chemical reactions, and then what else is being covered?
The moles. The moles, what we discussed,
How many questions was nomenclature?
18. 9 and 9, if you really care to know.
Oh, so 1 through 18?
1 through 18.
Okay.
They're worth 2 points apiece. The reaction questions are from 2 to 4. All 5 of the mole questions are 10 points each. So please be aware, the mole questions each are worth more than the individual questions of the nomenclature and the reactions.
Are the mole questions going to be multiple choice too, or type it out? Okay,
Yes.
thank you.
The mole questions are multiple choice.
Oh my Lord, thank
I
God.
tried to figure out how you could screw it up, and I put the screwed up answers in there as well. Like if you switch
Horrible.
things, you got to learn how to do it right, guys.
So there are no
Cool, but
short answers in this test. There are no short answers.
There is one.
How many hours is the test?
The last question, I couldn't figure out how to ask the last question as a multiple choice question. So it is a short answer question.
Okay. And whoever asked about the hours, I think he said it was 2 hours long.
I'm giving you 2 hours. You have from 8 in the morning until 7 at night. I don't think it should take you 2 hours. I really don't. Now, there are...
Test 2, right? I'm sorry.
Mila?
This is for test 2 on Thursday?
Test 2 on Thursday, yes.
Okay. Just wanted to make sure. I came in a little late.
There are 3 things I need to go over with you because I haven't discussed them. So let's get to that right away. Then we'll get into some sort of a review. Sorry, wait a second. Yeah. I have to figure out where I'm at. Okay, we have the 3 basic conversion factors. 1 mole is equal to the molecular weight, which is equal to 6.022 times 10 to the 23rd molecules. Or 1 mole is equal to the atomic weight, which is equal to 6.022 times 10 to the 23rd atoms. And you can interconvert any one of those 3. You can go from weight to molecules. You can go from molecules to moles. You can go from moles to weight. You can interconvert any of them because they're all equal to one another. We have one more conversion factor I got to talk about, and that is something called the molar volume. If you have a gas at STP, STP stands for standard temperature and pressure. This is 0 degrees Celsius, 273 degrees Kelvin, 1 atmosphere or 760 torr. Don't worry, I will tell you. I will either have the initials STP or I will tell you standard temperature and pressure. I will not give you a problem where you are going to have to try and figure it out through gas laws, which is something we're going to get to later. So a gas at STP, 1 mole of the gas gives you a volume of 22.414 liters. So if I have 450 milliliters of oxygen at STP, what is the mass? Okay. My conversion is between liters and volume. Since it's between liters and volume, I have to change my milliliters into liters. I am going up the chain. I'm going up the staircase. If I'm going up the staircase, each step is divided by 10. So going from milliliters to centiliters, divide by 10. Centiliters to deciliters, divide by 10. Deciliters to liters, divide by 10. All total, 1 liter is equal to 1,000 milliliters. Put that on your paper somewhere. Mila, you just gave me a dirty look.
I'm just trying to listen and copy it down. I'm sorry.
Okay. Write this down. Put it on your notes.
Professor, where did you get the 22.4 from? 22.4 liters.
That is, where did it come from?
Yeah.
Remind me when we do the gas laws and I'll show you where it comes from. Seriously, I can't do that right now because you don't know about the ideal gas law.
Okay.
It is derivable, but you have to know that before you can derive it. For right now, it's just a memorized thing. 1 mole of gas is equal to 22.414. So again, I don't have liters. I have to divide my milliliters by 1,000 to equal 0.450 liters. Since I have my conversion, 1 mole is equal to 22.414. I want moles because I want to get mass from that. So moles are going to go on the top, 22.414 on the bottom. I take my 0.450 liters, divide that by 22.414 liters. That gives me 0.0201 moles. Oxygen. Oxygen's molecular weight, because it doesn't exist as just O. Oxygen in the real world exists as O2. It's diatomic. So the relationship between 1 mole of oxygen and its weight is 16 plus 16, or 32. So if I have the moles, I just have to multiply it by the molecular weight over 1 mole. That will tell me how many grams of oxygen I have. Questions, ladies and gentlemen?
Professor, so even though the question only asks for oxygen, anytime we have a question of this sort, we are automatically doing O2, F2, N2. Is that what we're doing?
I have to be careful how I answer this question. If you are given the element, if it's...
Are there only just certain elements that we need to memorize?
I'm sorry?
Sorry, are there just only certain elements that we have to memorize that are diatomic? Would that be simpler thing to do?
Have no fear of ice cold beer. Have hydrogen, of oxygen, no nitrogen, fear fluorine. Have no fear. Have hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. If you're looking at the periodic table, take fluorine all the way straight down, fluorine over to nitrogen. Those are the ones that are diatomic. Now, in terms of your other question, when we want moles of the atoms, we are going to have to use the atomic weight. When we have moles of the molecule, we have to use the molecular weight. When we ask a question, oxygen at STP, we're implying that the oxygen is in the atmosphere. And how does it exist in the atmosphere? It exists in molecular form. So when you ask a question about oxygen and STP, you're going to use the molecular weight. Fluorine, you're going to use the molecular weight. Nitrogen, you're going to use the molecular weight. When you get back from spring break, we're going to get into something called empirical formulas. Empirical formulas, you're going to have to use atomic weight. For right now, for this test, I want you to think only if you see oxygen and the term STP, you're thinking O2. Other questions, guys, about this problem?
I have one, but it's kind of not about this problem. Like, I have like a molar map that has most of this information, but it also has RTP, and I didn't remember what that was.
RTP?
Yeah, it has 22.4 at STP and then 24.0 at RTP. for like the gas and volume and moles.
Room temperature and pressure.
Oh, okay. Thank you.
I'm sorry, Mariah. Honestly, right now, I'm guessing. I'd have to work it out. 24.0, you said?
Yeah.
I'll have to work that out. But Mariah, are you coming to lab tonight?
I have lab on Thursday.
Okay. I believe that's going to be room temperature. 298. Okay.
It's also referred to as NTP as well, if that helps.
Which, the 24?
No, the RTP and NTP apparently, according to Google, you can just change it, but it's not telling me what it actually stands for. So I'm very sorry.
Was that number? Oh, Mariah. Was that number 24.454?
For mine, it has the rounded answer, so it's only 24.0 on mine. So I don't know.
Yeah, I'm sorry, I don't know. I just did the math for the room temperature, and I'm sorry, I'm at a loss.
I think you're right. It is room temperature because NTP stands for normal laboratory room temperature. So,
and that was 24.4, Victoria?
I think so, yeah.
Okay. Mm-hmm. So, Mariah, that's what I believe it is. Okay? Mariah?
Yeah.
Okay, that's what I believe it is. All right. Okay. This is very, very important. Kind of like italics this or circle it in your notes. The gas has to be at STP. It has to be at 1 atmosphere pressure and 273 degrees Kelvin. Has to be there. If it is not there, then that relationship does not exist. As Mariah just pointed out, you change the temperature to 25 Celsius. You change that volume from 22.414 to 24.454. So it has to be at those two things. "28 grams of CO2 is how many moles?" Terry, how are we going to do this problem?
What was the question again?
28 grams of CO2 is how many moles?
1 mole.
Nope. Dimensional analysis. We know 28 grams, right?
Right.
So that goes on the left side. What goes on the right side of the equal sign?
Moles.
So when we do this, what's going to
Times
go on
Avogadro's
top?
number.
Nope. What's going to go on top, Terry?
Oh,
you guys are making it harder than it really is. All you gotta do is look over here. What's over here?
Moles is gonna go on top.
Thank you.
And grams is gonna go on bottom because that's what we're canceling out.
So Terry, the $40 million question. How do you relate moles and grams?
The molecular weight is 1 mole.
They're absolutely 100%. Carbon weighs 12. Oxygen weighs 16. 12 plus 16 is 28, plus another 16 makes it 44. So if I'm solving this problem, I'm taking 28 grams and I'm multiplying it by 1 mole over the molecular weight, which is 44. Grams cancels out. I'm only left with moles.
Professor?
Yep.
If we have this kind of periodic table that you can buy, like the quick study guide, it only rounds the weights to 4 sig figs where it rounds up. Can we use that, or do you want us to use the one that you gave us?
Okay. First of all, Victoria, let's think about this. My answers were using the periodic table that I used. Okay? And it would be a better idea to use the one I give you for the simple reason that the significant figures may be off.
Okay.
Yeah, you understand? You may round at a different time, and your answer may not be exactly mine. Does that make sense, Victoria?
Yeah.
If you have, this is the second thing I need to bring your attention to. If you have 12.045 grams of iron 3 oxide, how many grams of iron can this generate? Understand this. I'm not asking for grams of iron 3 oxide. I'm asking specifically for grams of iron. Terry, get back here. I need you to pay attention to this.
Yo, what was that?
Yo, I had to turn on the fan, yo.
Oh.
Okay, let's think about this for a second. If I have one molecule of iron 3 oxide, Jennifer.
Yes.
Okay, the formula for iron 3 oxide is up there. If I have one molecule of iron 3 oxide, how many atoms of iron do I have?
6.022 times 10 to the 20.
I have one molecule.
Oh.
One molecule of iron 3 oxide. How many atoms of iron do I have? What's the subscript, Jennifer?
So the sub 1.
No.
Oh, how many atoms of iron? 2.
2.
Oh, gotcha.
I got one molecule. The subscript for iron is 2. I got 2 iron atoms. If I have one molecule of iron, how many oxygens do I have?
3.
All right. Now, what I'm going to do with all that is instead of having one molecule, I'm going to have 6.022 times 10 to the 23 molecules of iron oxide.
Okay.
If I do that, then don't I have 2 times 6.02 times 10 to the 23rd atoms of iron?
Yes.
Yeah.
And don't I have 3 times 6.02 e to the 23rd atoms of oxygen?
Yeah.
Is there anybody that does not see that? So if I want to switch that to moles, isn't 6.02 times 10 to the 23rd equal to 1 mole?
Yes.
So I would have to divide that by 6.02 times 10 to the 23rd to get 1 mole, correct?
Yes.
If I do that, don't I have to also divide 1.204 e to the 21st by Avogadro's number? And don't I have to also divide 1.807 e to the 24th to get by Avogadro's number to get the moles of iron and the moles of oxygen?
Yes.
So if I divide that, I get 2 moles of iron and 3 moles of oxygen. I did that to try and explain to you why. If I have 1 mole of iron 3 oxide, 1 mole of this compound makes 2 moles of the iron and 3 moles of the oxygen. Are you understanding that? So there is a relationship between the subscripts and the number of moles of atoms there are within 1 mole of that particular substance. Does that make sense to you guys?
Yep.
Yes.
So 1 mole of Fe2O3 is equal to 2 moles of iron and 3 moles of oxygen. If I add the whole thing up, I get 2 times 55.845 and 3 times 15.599. I get Iron's contribution is 111.69. I get oxygen's is 47.997. I add those two contributions together, and the molecular mass for iron 3 oxide is 159.69. Okay?
Okay.
If I figure out how many moles of iron 3 oxide I have a relationship between moles of iron and moles of iron 3 oxide. So the first thing I got to do is find moles of iron 3 oxide. I take my 12.045 grams, divide it by the molecular weight, I get 0.075427 moles of iron 3 oxide. But remember, for every 1 mole of iron 3 oxide, I have 2 moles of iron. So I'm going to multiply my moles of iron 3 oxide by 2 over 1. That's going to give me 0.15085 moles of iron. All I have to do then is multiply by the atomic mass of iron, and I get my answer of 8.4245 grams of iron. Bottom line, you can relate a quantity of your compound to how much of that iron is, how much of that compound contains iron oxide. So in this case, 12 point something grams of the iron oxide contained 8.4245 grams of iron. Questions, ladies and gentlemen? Okay. Let's see who else is in here. Alec. You're out there, Alec. Let's go for Spencer. You're out there, Spencer?
Yes.
Okay. If you have 5.43 e to the 24th atoms, can you tell me how much it weighs? What do you know? What goes on the left side of the equal sign? What's the problem give you, Spencer?
It gives you the number of atoms.
Okay. So the 5.43 e to the 24th goes on the left side of the equal sign. What goes on the right?
Moles.
Alec said his mic isn't working and wants you to know.
Okay, no problem. Spencer.
Yeah.
You can go through moles, but what do you have to do to get from atoms to moles?
The atomic weight. I don't know.
Okay, Spencer. You want moles, you want to get rid of atoms. What's going to go on the top, Spencer?
No clue.
Okay, no, it's no problem, Spencer. Somebody help him out here.
Moles goes on the top.
Spencer, if you want to end up with moles, moles has to go on the top of your conversion. Remember, you're multiplying by a fraction. If you want to end up with moles, moles goes on the top. So Spencer, what are you trying to get rid of?
You're trying to get rid of the atoms, right?
Spencer, do you see that?
I'm a bit confused.
Okay, Spencer, we are only dealing with dimensional analysis problems. Okay? Damn it. Okay, we have 5.43 e to the 24th atoms. And we want to eventually get to grams because the question asks us grams. Okay, Spencer?
Okay.
So dimensional analysis says that we put something on top and we put something on the bottom. Right, Spencer?
Yes.
Whatever we want to end up with has to go on the top. Whatever we want to get rid of has to go on the bottom. Because if we're multiplying atoms by something over atoms, the atoms will cancel out, left with grams. Okay, Spencer?
Okay.
So you wanted to go through moles though. So in that case, we're going to have to put moles over, this is ridiculous. That's not what I wanted. This is what I wanted. Okay, Spencer, are you seeing this?
Yes.
If I want to go from atoms to grams and I want to go through moles, I have to get the relationship of moles to atoms. Atoms cancels. Then I have to do it again, but this time I do grams over moles. Moles cancel. Everything is canceled out here except grams.
Okay.
Does that make sense, Spencer?
Yeah, now it makes more sense that you drew it out.
No, you have to get the relationship. Do you know what the relationship between 1 mole and a certain number of atoms is?
Yeah, 6.022 to the 23rd? Or
Yeah, I'm going to try and do something. This is driving me absolutely crazy. Okay, so we have 1 mole divided by 6.02 e to the 23rd. Now, we also have the relationship of, sorry, I'm having a hard time seeing that. We also have the relationship of grams to a mole. We're talking about carbon. Where do you go to find out how many grams are in 1 mole of carbon, Spencer? Somebody help them.
Your periodic table.
Periodic table.
Periodic table. You look at the periodic table and you look that up and you will find in there the atomic weight of carbon. And you know that the atomic weight is equal to 1 mole. Questions, ladies and gentlemen? Mila, how much does 0.589 moles of chromium weigh? What do we know? What goes on the left side of the arrow?
The moles, the 0.589 moles.
Okay. On the other side of the equal sign, what do we have?
We're looking for the weight in grams.
Okay, so if I'm doing that, what's going to go on top? Grams or moles? Grams?
And then moles on the bottom.
What is the relationship between grams and moles?
It's the atomic weight.
Atomic weight. Do you have your periodic table with you?
Yes, it's 51.996.
So all I have to do is take my moles and multiply it by the atomic weight over number of moles.
Now, will the moles be that 6.0?
Nope.
No, okay, just kidding.
Mila.
Yes.
One mole is equal to 6.02 times 10 to the 23rd atoms.
Okay, so that's
equal to
doing atoms. Okay, I get that.
Which is equal to the molecular weight for chromium of 51.996.
Okay.
How many moles is 10 grams of carbon-14, H18, N2O5?
Go back to the last slide.
Hey, wait a minute.
Yeah.
I was gonna say you skipped that one quick.
What's that?
Can you go back to that last one? I don't even know the answer.
30.6.
Thank you.
Okay. Riddle me this. Somebody answer the question. Give me a strategy. How am I going to do this problem? What's the first thing I'm going to have to figure out?
Molecular weight.
Yeah, the amount of each element in that sequence.
Okay, I'm not going to, it's not worth my effort to go through all that stuff. Okay. Carbon. There are 14 of them there. There are 18 hydrogens, 2 nitrogens, 5 oxygens. Are you understanding now why a table would help you?
Yeah.
You're telling me to be quiet, Mila?
No, my kids are like at the age where when they watch movies, everything's like really funny. So he's just laughing right now.
No problem.
Sorry.
So if I have 14 carbons, I have to figure out what I have to find the atomic mass. Carbon's contribution is going to be 14 times that, which is 168 point whatever. My hydrogen, I've got 18 of them. My atomic mass is 1.88. The contribution is 18 point something. I got 2 nitrogens times 14.007, 28.014. 5 oxygens times 15.999, 79.995. I add all this crap together and I get 294.31. That is my molecular weight. So strategy-wise, what are we going to do here? I want to know how many moles is 10 grams of that crap.
Can you go back to that slide?
Now we have the molecular weight.
1 second, Mila. Okay, Hunter, we have the molecular weight.
Now we are going to set it up how we were setting up the ones right before this.
You tell me right now. What do I know?
Okay, let's put an equal sign on the left side. Let's put the grams over moles thing.
Hunter, do this one step at a time.
Well, wouldn't we start out with the molecular weight that we have?
Okay, let's start off with the molecular weight then. That's 294.31. Grams over moles, or gram over moles. And now we got to use that number to find the moles. And wasn't that, shit, sorry, what's the number again? Let me get my note.
You have everything you need to solve this problem here. Hunter, what do you want to know?
We want to know how many moles. We know how many grams there are.
Okay.
So would we do it the 294.31 grams times 1 mole over grams, and then that's going to equal our answer?
Wait. Mila, don't you already have that 1 mole over grams already?
Yeah, so.
I'm just kidding.
Wait, wouldn't it
Wait,
Wouldn't it be 10 grams times 1 mole and then divide that by the 294.31?
Let me write that down.
Who came up with the answer?
That was Hayden.
Good, Hayden. Very, very good. All you got to do, guys, in order to figure out what goes on top and what goes on the bottom, again, put what you know on the left side, what you want on the right side of the equal sign. Then put in the labels and then fill in the numbers afterwards. Do it stepwise like that. You'll have a lot easier time at it. I do this math out and I get 0.034 moles.
Now on a test, if you give us one like that, are you going to give us that table? Do we have to do that on the test?
You have to do the table.
Okay, thank you.
Questions on that one?
Howdy, are you going to do the scientific notation, or is it just going to be the 0.034, or can we do 3.4 e negative 2?
Remember, Christina, I'll be honest with you. I don't know what I did. I may have done it both ways.
Okay.
I don't know how I gave you. It's however I give you the answer in the table.
Okay.
Okay.
Thank you.
How many grams is 1.56 moles of the stuff? Well, if I have 1.56 moles and I want grams, then grams is what I want. So that's what's going to go on top. Moles is going to go on the bottom.
And then you would divide by like the molecular weight, right?
Wait, Terry, what's on top? What's the molecular weight? Is the molecular weight in grams?
Yeah.
So what's going to go? Which number is going to go on top? The 1 or the 294?
The 1.
No, 1 gram doesn't equal 294 moles, Terry. It's the other way around.
The other way around. Sorry.
The grams equal 1 mole. When you're doing grams per mole, the mole is always going to be 1. So this is 294.31. And that is going to be, I've already erased the number. We'll go with 460. Okay, Terry, that was disturbing. That really was disturbing. Okay.
Wait, which part?
When you started to put the 294 moles over 1 gram.
Yeah.
All right.
I had it backwards in my head.
Okay, make sure you don't have it backwards on Thursday, okay?
Roger that.
It's always 1 mole. 1 mole is equal to the molecular weight. Okay, Terry?
Yes, sir.
Okay. Let's get into ionic and net ionic equations. An ionic equation, what we are doing is we are taking the balanced chemical equation and we're breaking up the ions. We're breaking up the ions such that we are multiplying the coefficient times the subscript to get the number of the ion. We're putting that ion's chemical symbol, the charge on that chemical ion, and we also need to put the state. So if I have 4 NABR, Christina, break that up into its ions. I just caught you right as you shoved it in, right?
Yeah, you did. Sorry.
I'm sorry. No, I apologize to you.
Sorry, I worked all day too, haven't eaten.
4 NABR. What are the 2 ions that NABR is composed of?
Na and Br.
Na and Br.
Okay, that was too, I'm sorry, I was too easy. That was too easy. Okay, go ahead, I'm sorry.
So how many NAs do you have?
4.
What's the charge on an Na?
+1.
So, and it's in aqueous, so I call that 4 Na plus aqueous. Plus, how many Brs?
4.
What's the charge on Br?
-1 or negative.
And?
Aqueous.
Aqueous.
Okay.
Okay. Let's see, who else do I want to? Shamira, I haven't bothered you in a long time. Shamira.
Hi.
Hi. Okay, Shamira.
Yes.
Can you tell me how many leads we have?
4.
The 4
1.
only modifies what it's next to. The
1.
4 is only modifying the NO3.
Mm-hmm.
What number is right beside lead? It's assumed.
1.
1. So I have 1 PB. All right, now we got to think of what the charge on the PB is. If each NO3 is a -1, how many do I have, Shamira?
If each NO3 is a -1.
How many of them do I have?
I don't know.
Somebody help me. The subscript is 4, Shamira, so I have 4 of them.
Yeah. Okay.
So what's my total negative charge?
-4.
So what does that mean the lead has to be?
-4.
No, it has to balance the -4. Remember, the whole molecule has to be equal to a 0 charge. So we have a -4 that has to be balanced with?
-1.
+4.
What, Shamira, what do you add to -4 to make 0?
4.
+4.
Yes.
So the charge on my lead is a 4+. There's 1 of them. It's aqueous.
Okay.
Okay. How many NO3s did we say, Shamira?
You said 4, right?
4. So we got to put the 4 down there. The ion is defined as NO3, 1-. We also have to put the AQ there.
Okay.
Okay?
Yes.
Marie.
Yes.
PbBr4 solid.
Okay.
Split that into ions. Are you supposed to, Marie?
No, it's a solid, right?
It's a solid. Absolutely good. I was trying to trick you up and I didn't. It's a solid. It stays together.
Yes.
All right.
Mm-hmm.
So I have 4 NaNO3s. How many sodiums do I have?
4.
4.
Mm-hmm.
Designated by the Na.
Yes.
Charge on sodium, Marie. What did we say it was before?
+1.
+1. Put the +1 there, aqueous. So
Mm-hmm.
Marie, how many NO3s do I have?
4.
4 NO3s. What's the charge?
-1.
And the
Parentheses.
AQ, aqueous. Okay.
Yes.
Good, 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 good.
Will a solid always have an S there?
Yes.
Okay.
Yes, Curtis. Speaking of which, I think I caught you on this the last time. Yeah, you do this just to make yourself look good, right, Curtis? You type in right when I'm about to ask the same question I asked you on Monday, right? Or last Thursday, right? What's the same, Curtis?
Just coincidence.
What's the same in this equation, in the ionic equation? What's the same left and right side of the arrow?
What is the same?
Yes. All right, you see where my
The
arrow's
charge?
at? No. Okay. what I've highlighted here, nope, not everything. Those are the reactants. Then I have the arrow. The products are down below.
Okay.
What is the same on the reactant side that's the same on the product side?
The 4Na and
Good.
the 4NO3.
4NAs and the 4NO3s. We're going to get rid of them. And what's left is Pb plus 4 aqueous plus 4 Br minus aqueous yields PbBr4 solid.
I have a question.
I'm here.
On the products, why isn't the PbBr, why isn't that one like separated into two?
Because it's a solid. If I would put NaBr and PbNO3 together, I would get a yellowish solid that would precipitate out. It's no longer in solution, Hayden. That's why it's got this S there. It is now clinged together as a solid on the very bottom of this reaction.
Okay, so only the aqueuses get separated.
Correct. Okay. Only the aqueuses get separated. Now, guys, I got to bring up my third point here. This one's easy, okay? There's a concept called sum of the coefficients, and it is just what it says. All you got to do is add up all the coefficients of the balanced reaction. Assume there's a 1 if there's no number before the compound. So if I have the reaction 2CaBr2 plus plus PbNO3 yielding PbBr4 plus 2CaNO3 taken twice, I'm going to count up all the coefficients. There's a 2 in front of the CaBr2. There's a 1 in front, that's assumed. There's a 1 in front of the PbNO3. There's a 1 in front of the PbBr4. There's a 2 in front of the CaNO3 taken twice. So I add up all those coefficients, 2 plus 1 plus 1 plus 2, I get 6. So if I ask you what is the sum of coefficients of this reaction, the answer to that question would be 6. It's a way for chemistry professors to ask you if you balanced a chemical question without. It's an easy way for us to ask that question, but I have to have you understand the term sum of the coefficients. Okay, if I react 6 NAs plus Al2O3 to give me 3 Na2Os plus 2 Als. The coefficient in front of the Na is 6. No number in front of the Al2O3, that's a 1. There's a 3 in front of the Na2O, and there's a 2 in front of the Al. I add 6 plus 1 plus 3 plus 2, I get 12. Easy peasy, guys?
Easy peasy.
Okay, Curtis, I am going to, screw it. I have this big long thing. I can do sum of coefficients with ionic and net ionic as well. So to get the sum of the coefficients of this whole thing, I got to add the 4 plus the 4 plus the 1 plus the other plus another 4 plus this 1 plus 4 plus 4. I add all those things together, I get 22. So I'm not just limited to a regular balanced chemical equation. I can ask the same thing of a balanced ionic equation as well. We good with that? Okay, 3 new concepts I introduced tonight. One was molar volume. That gives us another conversion factor. At STP, 1 mole of a gas has a volume of 22.414 liters. Second concept I got across to you. if you have 1 mole of a compound, the number of atoms, the number of moles of atoms is equal to the subscript. So if I have Al2O3 and I have 1 mole of that, I have 2 moles of aluminum, 3 moles of oxygen. Third new concept I just got across was sum of the coefficients. And all you do is you look at all the coefficients in your balanced equation, add them all up, you get the sum of the coefficients. Right now, questions about those 3 aspects? All right. I'm going to throw it open to you. This is supposed to be a review session. I'm going to throw it open to you. We got 20 minutes left. Anybody have questions about something?
I just have a quick question about the PowerPoint. Are you going to put it up at some point tonight so we can review this again by ourselves?
I know that yeah, I will put it up.
All right, thank you.
Professor, how do you go back and watch previous lectures? Because I know you record these, but...
Okay, there are 2 ways to do it. And actually, I don't know the first way. I just know that you can do it. I'm going to have to ask somebody's help. You can actually access it directly through YouTube.
Oh, you can?
Yeah. Somebody that's done that. What do? Just type in my name there or what?
I tried to. You have them unlisted.
I know that people last year were able to do it. I'm just not able to do it that way. Otherwise...
Professor, do you have so you post them on your YouTube channel?
Hold on a second. I'm sorry, what?
So you post them on your YouTube channel, right?
Yes.
If you go to course contact and then go to the
I'm just going to show it that.
Okay, I was gonna say there's like a web page that you post.
Okay. We're in course content, right? Or we're in the home page.
Yeah.
If you click on the course content, you go down to the modules where it says Zoom meetings.
Mm-hmm.
Click on that. Go up. And if you click on this, this will download a WordPerfect document. But then all you have to do is Control left click. And it will load it up. Are you seeing this?
No, but I'm going with you.
Okay. Okay, you seeing the screen right now?
Yeah.
Okay. When you are in this screen, all you got to do is, you see the blues that are highlighted? Mm-hmm. All you got to do is put your mouse on there, Control left click. And are you seeing the screen that's on there now?
Yeah.
Okay, you're seeing the video, right?
Mm-hmm.
That's as quick as it is.
All right, thank you.
Anything else, ladies and gentlemen?
I know you did this a while back, but can you go over just briefly how to find the positive and negative charge of an element?
Sure.
Thank you.
Go share screen. Get back to here. Okay. There are 2 ways, Curtis, to do it. All right. I'm going to show you the easy way first, and then I'm going to show you the hard way. Okay. Do you see where the subscripts are there, right?
Yes.
Okay. Now, and I got to see this. Okay, you see the purple line?
Mm-hmm.
Ah, crap. I got to do it this way. There we go. What you do is you take the subscript 3, you put it up there. That will give you the positive charge on the aluminum. Okay, Curtis?
Okay.
This is the easy way to do this.
So we just ignore the 2? We don't?
Nope, wait, 1 second.
Okay.
Okay. No, stop it. Thank you. Okay. All right. So wherever you see the 3 there, you're doing a cross thing here. So that what happens is the aluminum would be a +3, and the oxygen would be a -2. The 2 came from the subscript on the aluminum. The 3 came from the subscript on the oxygen. Okay? That will work 95% of the time. There are going to be times, though, when it doesn't work. Okay? This happens to be one of them. If you did that same thing, you would say that the tin was a +2 and the sulfur was a -1, right?
Yeah.
Now, look, Curtis, look in your periodic table. Okay? Do you see where oxygen is?
1 second. Yes.
Okay. Now, do you know what the charge on oxygen is, Curtis?
I do not know. I know it's in the 3rd row from the right.
So it needs 2 more electrons to make it 8, right? It needs 2 more to get to the noble gases, right?
Okay.
So if it needs 2 more, then it's going to have 2 more electrons than it does protons. What's the charge on it, Curtis?
-1.
No, it needs 2. It has
-2?
-2. All right, so here's what I want you to do. Above hydrogen, do you have the ability to mark your periodic table, Curtis?
No. It's on my phone.
Okay, above hydrogen, or put on a notepad, hydrogen +1.
Okay. Wait, matter of fact, I can mark it here.
Hydrogen +1. So everything below hydrogen in the periodic table is going to have a +1 charge.
Okay.
Next element over, beryllium, +2. Everything beryllium down will have a +2 charge.
Okay.
Now I want you to go over to nitrogen, which is 1 to the left of oxygen. Put a -3.
Okay.
So everything from nitrogen down to the staircase will have a -3 charge. Oxygen, 2-. Oxygen down to the staircase will have a -2 charge. Fluorine, -1. Fluorine, everything below it's a -1. Okay, Curtis. So you see that sulfur has to have a -2 charge. Has to have a -2 charge. But if you just did the cross thing,
it'd be -1.
The subscript, yes. So it won't exist like that. So what you have to do is you have to figure out what the total negative charge is. So for sulfur, there are 2 S's, right?
Right.
Each one of them is what? Charge, 2-, right?
-2, yeah.
So this equals 4 minuses total.
-4.
All right, now, in order for SN2 to exist, it has to be a neutral molecule. So that 4- has to be balanced by 4 pluses. So I know that above the 10, this is going to be a 4 plus.
Right.
Now,
but the other one wasn't, the first example wasn't balanced, right? It was a 3 plus on the left side and a 2 minus on the right.
Okay, there are 2 aluminums.
Over the review?
There are 2 aluminums, Curtis, right? 2 times a plus 3 is a plus 6. There are 3 oxygens times a minus 2, a minus 6. Plus 6 and minus. Okay.
Got you, multiplied. Okay.
Now, whenever you have this charge, if there happened to be like a 2 there, a 2 subscript, then I would have to take the 4 plus and divide it by 2, and each 10 would be a plus 2 charge.
Gotcha.
Okay, something else, guys. Something else, guys.
Yeah, can we just do a mole problem real quick so that I have a little bit more practice doing it?
A mole problem.
Same here. Like a conversion.
Okay. Oh, this is a lovely, I love this. I just, by the way, I'm doing this, I'm blowing the extra credit question. Nah, I'm going to leave it as the extra question. What do you want to do, Victoria?
You know what? I'm going to let dealer's choice. I can use any kind of practice. Oh, okay. Hold on.
Put that L down.
Ugh, I'm about to take an L on this problem.
You have 35.4 liters of NO2. How many grams is it?
Okay.
All right.
So from this example, we have to go from liters to moles to grams.
Okay, so we've got, what do we know?
So we have 34.5 liters, not hashtag a $sign.
Yeah.
So then we
Is somebody wait, Tom, is somebody playing a video of me? If somebody's got a video on of me, please kill your mic.
Wait, what?
I don't.
Professor, you may have.
Somebody is. Oh, is that me?
Yeah, you may have played it when you opened it because I didn't see you close that tab.
Wonderful. How do I stop it? Oh, that's how I stop it. Okay, thank God. Okay. All right. All right. Victoria, you said you were going to go through what?
Liters to moles to grams.
Okay.
So we have to do 1 mole over 22.414 liters. I guess I should get my calculator out. So 34.5. I got with, you want me to round to sig figs on this one?
Did you get that?
I got 1.54. Yep.
Okay. So now you got 1.54 moles.
Right.
You're going to have to get.
And then, okay.
Okay. What do you want? What do you want?
We need to go from moles to grams. So we have to find the molecular weight of NO2.
Okay.
So nitrogen would be, 1 nitrogen would be 14.0067.
Close enough.
And then oxygen is, you could just do 16, yeah, 32. And that's 46.01. Okay. So
remember, guys, this is grams per mole. This is grams in 1 mole, grams per 1 mole.
So will we do 1.54 moles times 46.01 over 1 mole? Oh, God. Math is power. I got 70.9 because I'm going to round it. Or 70.86, I guess, if you want to.
I would have gotten 70.8, but
okay.
Close enough.
Yeah.
Close enough. Okay.
Okay.
Victoria.
Yeah.
You didn't hesitate in any of that. Did not hesitate.
Like, I had the survival guide open, so I cheated a little bit.
Remember, I do not disallow the survivor guide.
Okay. It'll help you survive.
Professor, where's the periodic table that you're using? I mean, I have one, but it's got all those, it's got way too many numbers on it.
I'll see if I can pull it up. Okay, stop share. I can't do that, damn.
Is it just the one on the bottom of the test? Is that what you want to say? Is there one on the bottom of the test that you want us to use? Oh, okay. Okay. No worries. That works for me. Thank you.
Yeah, there will be one on the bottom of the test.
Okay. Thank you.
Come on, guys. I got 6 minutes left. I think it's pretty well split up through the 3 different things I talked about.
Maybe a little bit of like some nomenclature review.
Okay, Hayden. You want to go through nomenclature review after the 126 questions?
Yeah.
Wait, what?
Okay, Hayden. What's the first question I tell you to ask?
Oh, if it's ionic or covalent.
If the first element is a metal. Okay?
Okay.
Metal, you use ionic rules. Okay? Second, you ask, is the metal? Hayden?
Maybe like type 1 or type 2.
Type 1 or type 2. What's the difference?
Doesn't type 1 only have one possible charge?
Very good. Absolutely. You're doing this
Type
great.
2 could have more than one.
So how do you tell the difference?
Doesn't it depend on the anion?
No, that's how you determine whether what the charge is by the anion. But Hayden, how do you determine whether something's a type 1 or type 2? Hunter's already blurred it out.
What did he say?
How do you tell if it's a type 1 or type 2, Hayden?
Isn't there just like a list of them? I don't remember. I forgot how to figure that out.
Okay. Hayden, go ahead. Somebody explain. Yell it out.
If it's in the first 2 columns of the periodic table, then it would be ionic. If it's like the transitional metals besides like aluminum, silver, zinc, and cadmium, I think, then it's covalent bond.
No.
It's a type. Sorry.
We're trying to differentiate between type 1 and type 2. You got the general idea, Victoria.
Right.
Column 1, column 2. Remember, as I was telling Curtis, column 1's always going to be a +1 charge. Column 2 is always going to be a +2 charge.
And that would be type 1.
Those would be type 1. Then there are the 4. What are the 4 again, Victoria?
Silver, zinc, cadmium, and aluminum.
Those are the ones that are special. Those
Roman
four
numeral.
metals only have one charge. Silver is a +1, zinc is a +2, cadmium is a +2, aluminum is a +3. So those are all type 1s. Hayden, do they need a Roman numeral? Hayden, do they need a Roman numeral?
No.
Okay. She said no. Okay. Hayden, somehow your mic's fading out on me.
Oh, sorry.
right.
Is this better?
That's much better.
Okay.
All right. So you have a type 2 metal. Say you have something like, what do you do to determine the Roman numeral? What's the Roman numeral indicative of? The charge, not on the anion, the charge on the cation. Because the cations are the metal, right? So Hayden, you got to figure out what the charge on the cation is. Marie, what's the charge of each chlorine?
-1.
How many of them do I have in CuCl2?
What is the question? Sorry.
I have CuCl2.
Okay.
You
yes.
said each chlorine is worth a -1. How many of them do I have?
2.
So what's the total negative charge?
2. -2.
So what is the charge on the copper?
-1.
No. Marie.
Oh, to balance them, it has to be 2. -2
+2.
+2.
And by the way, Hayden, I did hear you and you were correct when you said +2. Now, throw it out there. If copper is a +2, name it.
Copper and then the parentheses 2. Chloride.
Absolutely. Absolutely.
Okay.
Then what you do, Hayden. Okay, you ask yourself, is the anion composed of one or more elements? If yes, it's monoatomic, root plus IDE. As you said, this is chlorine, first syllable chlor, and an ID. So the total name is going to be copper, parentheses 2, chloride. Now, if I have a sample where something is, no, I don't want to do this to you. I don't want to do this to you. Okay. I look at the first element and it is not a metal. I can't use ionic rules. I have to use covalent rules, which means I have to use prefixes. Yeah. I look at the first element. If it's 1, no prefix. If it's more than 1, I use a prefix. Hayden, so which prefix do I use for the S? Tetra?
Yeah, tetrasulfur.
Tetrasulfur.
And pentabromide.
Hayden, honestly, you need a little more confidence in this. You really do. Because you're getting it, you're giving me the right answers. You're giving me the right answers. You just need a little more confidence.
Say it with your chest.
What's that, Terry?
You got to say it with your chest, sir.
Is that an Army thing?
A little bit.
There we go. Absolutely. In other words, you got to be confident. Be confident when you give your answers because Guys, you know this stuff. You do know this stuff.
I have to go. I have to go to work. So thank you.
No problem. It's after time anyway, guys. I got to close this up. Does anybody have any absolute imperative stuff they need to talk about?
See you in lab.
Professor.
If so, I should be available tomorrow afternoon.
Hey,
I
Gabe,
should be available. Okay? And I should be available most of the morning as well.
Hey, Professor, do we have lab today?
Yes.
Oh, great. Okay.
All right,
Yes, we do.
Bye.
I will see you in lab.
All right, bye.
Bye.
Bye. Bye, Marie. Aaron's gone. Omar's still here. Alec, you still here? Chat if you're here, Alec. Omar. Questions, guys?
No question. Thank you.
Okay. Take off, Alec.